In the next few minutes, I'd like to describe to you some of the work going on in my lab. As you can see, we have quite a long list of research projects, all of them focusing on the use of ultrasound imaging in various diagnostic and image-guided therapy approaches. Many of them involve 3D ultrasound, which is technology that we've invented in the lab and applied it to many applications. And now I'll show you just a few applications just to give you an idea of what we're doing. The first technology I'd like to show you is 3D ultrasound imaging technology that we've used for developing prostate biopsy system as well as a prostate brachytherapy system, which is a procedure in which radioactive seeds are inserted into the prostate to treat cancer. As you can see on the left side is a 3D image of the prostate. The region in the central darker region is the prostate, and above it is the bladder. On the right side was the image being sliced and diced using our software. All this technology has already been used in clinical trials and has been licensed to a company which is selling it worldwide. Another application is image-guided focal liver ablation. This uses applicators which are inserted into the liver, into a tumor, and then they are either radiofrequency or microwave energy is used to ablate or thermally heat the tumor to destroy it. On the left side, you can see a 3D image in which the applicator has been segmented. The red region is the ablation zone that's provided by the manufacturer of the therapy applicator, and the blue outline is shows the tumor. On the right side is another view that we can show to the radiologist, interventional radiologist, to decide whether the applicators are in the right location. Another technology we have developed is 3D ultrasound imaging of the carotid arteries. In this technology, we can image the plaques in the carotid arteries in 3D and measure their volume. And what's most important is being able to image these patients serially over years to see whether the therapy that's these patients undergoing various medical therapy procedures, so that to see if the plaques are stabilizing or in fact diminishing. So this technology has already been licensed to a company and is being used widely. You can see the carotid arteries were shown in dark, and you can see the plaque just sitting at the entrance to the internal carotid artery, which demonstrates that it's quite an important, very significant plaque. Another technology we have developed is 3D ultrasound imaging of preterm babies. And these babies, some of them may have bleeds into the ventricles, which tend to expand, putting pressure on the rest of the brain. Using our technology, we can image these babies in the incubator. So they're quite small. And if they're preterm, they're you can't really move them too much. But using our technology, we can image them directly in the incubator to be able to measure their ventricles to see if they're resolving or in fact increasing, and therefore intervention is needed. So in summary, you can see that we have quite a few projects. I've just showed you a few of them. We have many patents that cover these projects. We have a span of 3 companies. We have many clinical collaborators and projects in which the clinical collaborators test our technologies. And we have quite a large team of mechanical and software engineers, and of course many graduate students and undergraduate students. In our lab, we can take a basic idea, in fact, our unmet need provided to us by clinical collaborators, and we can then develop the concepts, invent technology, hardware and software, build it in the lab, test it in the lab, and then clinically translate it for testing in the hospital or in colleagues across the world, actually, and then potentially translate it to a company. So I hope you get a sense of what we can do in our lab.